All right, here we go. This is part 2 of the final exam review. Number 51, the perimeter of a rectangular garden is 72 feet. Write a system of equations that can be used to find the dimensions of the garden if its length L is 3 times the width W, then solve for W and L. So we know with systems we're going to need two different equations. We need to write our let statements first. So I'm going to say let L be length and W be width. Okay, so it says the perimeter, which means we're going to need to use the formula 2L plus 2W. So I've got 2L plus 2W, and that's equal to my perimeter. Okay, and then it says the length is, L is means equals. So I've got L equals 3 times the width, so 3W. All right, so there's my two equations. Now I just need to solve for L and W. The way that this one is set up, the easiest way to solve this is going to be substitution because we know what L is equal to. So I'm going to take what L equals and I'm going to substitute that in for L. All right, so we have 2, and then I'm going to take that little box and plug it in. So I have 3W there plus 2W equals 72. 2 times 3W is 6W. Plus 2W equals 72. Add your 6W and 2W, so you get 8W equals 72. And divide by 8, so you get W as 9. Now I'm going to take that 9, I'm going to plug it back into one of those equations. Obviously the easier one would be L equals 3W. So if I have L equals 3 times W, so 3 times 9, that means L is 27. Okay, number 52. Find the solution for the system of equations. Now the way that this is set up, since they're both in standard form, the easiest way to solve this one is going to be by elimination. Okay, so what I need to do is decide which variable do I want to get rid of. So let's say I want to get rid of x. So I'm going to multiply everything by a negative 2.5. That way those x's cross out. So if I distribute that all the way through, I have negative 2.5x minus 2.5y equals negative 2.5 times 12 is negative 30. I'm going to rewrite that other equation back under it. And then we're going to add down. So my x's are going to eliminate. I have negative 2.5y plus 7.5y, that's 5y, equals negative 30 plus 75, that's 45. And divide by 5, that means y is going to be 9. I'm going to take that and plug it in. It's going to be easier to plug it into that second equation, the original second equation. So I have x plus y, now we know is 9, equals 12. Subtract 9 from both sides. So we now know x is 3. You can take those and plug them back in and check them if you want. 53, simplify the following. State your answer using positive exponents. Okay, so when you multiply with exponents, you're going to add them. So a to the 3rd times a to the 7th is a to the 10th. B, if I add these exponents, that gets me k to the negative 5. But remember, you can't have negative exponents. So to get rid of that, that needs to get flipped. So I'm going to have k to the 5th on the bottom, but you can't have nothing on top, so you're going to have a 1. C, if I write this using positive exponents, when I divide, I'm going to keep my base. This one's a little bit different. Keep my base of 8, and then 6 minus 2 is 4. So if I write it with positive exponents, it's 8 to the 4th. But if I actually get that answer, a to the 4th power, that's 4,096. Okay, D. Okay, now notice this exponent's on the outside, so I need to take this that little 3 and distribute it to everything in there. Okay, so I have 2 to the 3rd power, that's 8. Remember, you have to put that power on the 2, so it's 2 to the 3rd, you're not multiplying those. Okay, now we're going to multiply exponents. And remember, these rules are on your formula chart. So if you get confused with these, they're on the formula chart. So p to the 9th, r to the negative 12. But we can't have negative exponents. The only thing that has a negative exponent is the r. So that r is going to have to get dropped. So on the top, I have 8 p to the 9th, but on the bottom I have r to the 12th. All right, 54. Which expression is equivalent to the square root of 2x squared to the 4th power? So the first thing I need to do here is distribute that little 4. So I'm going to put it on the 2, and I'm going to take it to the x squared. So that's 2 to the 4th power, which is 16. And then 2 times 4, that's x to the 8th. Now I need to take the square root of this. So I actually know the square root of 16, that's 4. And then the square root of x to the 8th is x to the 4th. Remember, that's because x to the 4th times x to the 4th. When you add those exponents, that gets x to the 8th. So what you can do is when it's even like that, you can just cut it in half. So the answer here is B. 55, if y plus 2x cubed, write an expression for y cubed. So what they have done is they've taken this y and they've cubed it. Well, if you cube that side, you also have to cube the other side. That's what algebra is all about. What you do to one side, you do to the other. So I need to take that 3 and distribute it. So that's 2 to the 3rd power, that's 8. Now this is a power to a power, so I'm going to multiply those and get x to the 9th. 56, what is the sum of k cubed plus 2x squared, or 2k squared plus 1 and 3k squared minus 4? So I'm going to add all this up. And I can really just add this. I don't need to rewrite it all. Okay, I have k cubed. That's my only cube. So I've got k cubed. I'm going to cross that out. I have 2k squared plus 3k squared. So that's 5k squared. And then I have 1 minus 4, which is a negative 3. 57. Write x plus all that stuff as a simplified polynomial, all right? So I've got to take these things in here, and I'm going to have to do some distributing. So we have x plus, if I distribute 3x times x, that's 3x squared. 3x times 2 is 6x. Minus 5 times x is minus 5x. Negative 5 times 2 is negative 10. Plus 2x times x is 2x squared, and 2x times negative 3 is negative 6. Now I need to look at this baby and see what like terms we have. You want to start with the highest exponent stuff. So I've got a 3x squared and a 2x squared. So that's 5x squared. I'm going to look at my x's next. I have a 1x, a 6x, and a minus 5x. That's 1 plus 6 is 7. 7 minus 5 is 2. So I have plus 2x. And then I have, oh, I missed something. Hold up. When I distributed this 2x to this negative 3, that needed to be minus 6x at the end. Okay, so let's go back. So our 5x squared, we know that's right. But now I've got x plus 6x minus 5x minus 6x down here. So I've got 1 plus 6 is 7. 7 minus 5 is 2. 2 minus 6 is negative 4x. And then this is my only constant, so minus 10. 58. Simplify 2x to the 4th times all of that stuff. So here we go. We're going to take this 2x to the 4th and distribute it. Remember, when you multiply, you add exponents. So that's 6x to the 7th minus 2x to the 4 plus 2 is 6 plus 2 times 5 is 10. X to the 4th and x, that's x to the 5th. We don't have any like terms there. 59. If x equals y squared minus 2y plus 5 and z equals y minus 2, what is 2xz? So that's what is 2 times x times z. So what would be easiest here is if we go ahead and do x times z, and then we'll multiply that whole thing by 2. Okay, so I'm going to write this out so it's easier to see. I'll save the 2 for a little bit. Okay, so y squared times y, that's y cubed. Y squared times negative 2 is minus 2y squared. Now I have negative 2y times y, so that's minus 2y squared. Negative 2y times negative 2 is plus 4y. Now I have 5 times y is 5y, and 5 times negative 2 is minus 10. Now I'm going to combine my like terms. This is my only y cubed, so I have y cubed. I have a negative 2y squared minus 2y squared. That's not 0. That's negative 2 minus 2. That's negative 4y squared. And then I have 4y and a 5y. That's 9y. And then I have minus 10. Okay, now that was x times z. Now I need to multiply that times 2. So I've got 2y cubed minus 8y squared plus 18y minus 20. Number 60, write a polynomial that is equivalent to 3x squared plus 5 squared. Okay, not really a shortcut here, so you've got to write this out. 3x squared plus 5 times 3x squared plus 5. You cannot take that little 2 on the outside and distribute that. It's not going to work. So now I FOIL this. So 3x squared times 3x squared, that's 9x to the 4th. 3x squared times 5 is plus 15x squared. Now I have 5 times 3x squared again, so that's again 15x squared. And then I have 5 times 5 is 25. We have a couple of like terms here in the middle. So that gets me 9x to the 4th plus 30x squared plus 25. 61, write an expression that is equivalent to that. So here we go, we're going to FOIL again. So I have x times y is xy. X times negative k is minus xk. The inside, negative k times y, so minus ky, and negative k times negative k is going to be plus k squared, which is C, because there's no like terms. 62. The area of a rectangle is given by the equation h squared equals 10h minus 25, where h is the height of the rectangle. What is the value of h? So you're trying to figure out what is the solution here, which means we can do this in our calculator, but there's something you have to make sure of first. You've got to get this whole thing equal to 0, and you want to keep that h squared positive. So you want to keep that there, but these other two things we're going to have to move over. So I'm going to subtract 10h and move it over, and I'm going to add that 25 and move it over. So we have h squared minus 10h plus 25 equal to 0. Now, if you wanted to factor this, you could, but if it were me, I'd want to just get my answer from the calculator. So I'm going to go to my y equals, and I'm going to type in this equation. So I've got, where'd my equation go? I've got x squared minus 10x plus 25. I'm going to graph it. And you're going to notice something special here. You're going to notice that there's just one solution. It's only touching the x-axis once. Okay, so we only have one solution that we need to find here, which is really nice. So from here, I'm going to go to second trace. We want the 0, so number 2. Okay, right now my cursor is at 0.25. So I'm going to bring that down where I can see it. Okay, I need to get to the left of my 0 and the right of my 0. Now it's confusing here because your 0 is also a minimum. It's the lowest point. So I've got my left bound. I'm going to right click over to get to the right side, then enter, and then enter one more time. And there's my answer. Now mine says 4.9999981, but that obviously rounds up to 5. So in this case, the height is 5. You could have factored that. If you did, you would have gotten h minus 5 and h minus 5 equals 0. Well, when you set that equal to 0 and you add 5 to both sides, you end up with h is 5. So it's exactly what we got from the calculator. 63, determine the zeros. Again, on this one would be really easy to factor, but you might as well get the zeros from your calculator. So I'm going to go to my y equals, and I'm going to type this in. So I've got x squared minus x minus 72. I'm going to graph it. Now, since this is multiple choice, you could honestly, on one like this, because it's so clean, you could just count these little tick marks and see where these cross. To save a little bit of time, that's what I'm going to do right now. So I'm going to get this one on the left. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So that's -8. And then on the right, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got -8 and 9. Or you find the zeros by doing second trace and finding the zeros that way. All right, number 64, which set of ordered pairs satisfy that function? So I'm going to take that function, I'm going to plug it in my y equals. I'm not even going to try to figure this out on my own. So I'm going to type in x squared minus 5x plus 3. And it looks like I'm comparing this to tables, so I'm going to pull up my table. I can see that one -1's in there, so that means the answer choice A is gone. And I've got 2 -3, that means answer choice B is gone. And then I've got 3 -3, which means my answer here is D. Pretty straight up question here. Write an expression that is equivalent to 5 over square root of 10 that does not have a radical in the denominator. So you remember, you cannot have radicals in the denominator, so you have to know how to rationalize this. So whatever radical is in the denominator, you're going to multiply it by that over itself. So I'm going to multiply this by the square root of 10 over the square root of 10. Okay, and when you multiply fractions, you know you multiply straight across. So on the top, I have 5 times square root of 10. That's just going to stay as 5 square root of 10. Outside times outside, inside times inside. And then on the bottom, square root of 10 times square root of 10. Remember, any square root times itself is the number underneath. So that is 10. Square root of 10 times square root of 10 is 10. You can think about it as the square root of 100, but the square root of 100 is 10. Now you have to look at this and see, is there anything else you can simplify? Well, 5 over 10, that's going to go down to 1 over 2. So I have the square root of 10 over 2. You need to make sure that 10, that there's no perfect squares in that number, but there's not in that number, so we are good. Okay, number 66. A ladder that is 20 feet long is placed against a house. The bottom of the ladder is 10 feet from the base of the house. How far up the house does the ladder reach? Okay, we've done enough of these to know that you're going to have to use Pythagorean theorem here. Okay, so obviously this is our ladder that's leaning up against the house. This is going to be the house, side of the house, and then you've got the base or the floor or whatever we're talking about. You need to make sure you know what each side is so you know where to put these numbers. So you've got the ladder is 25 feet long. So there's my ladder side. The bottom of the ladder, so the bottom of the ladder down here is 10 feet from the base of the house. Okay, so that's 10 feet. And it's asking how far up the house does the ladder reach. So we're trying to find that house side. Okay, so I'm going to use a squared plus b squared equals c squared. I'm going to say my a side is x. So I've got x squared plus my b side is 10. And then your c has to be your hypotenuse. So that equals 25 squared. Keep working this out. So I have x squared plus 100 equals, I think that's 625. Subtract the 100 from both sides. You get x squared equals 525. I'm actually going to move that over here. So the square root of 525. Now A says write the answer as a simplified radical, which means I've got to simplify this. Remember, if you want to look for factors, you can go to your y equals. You can type in 525 divided by x and pull up your table, and you can see everything that multiplies to be that. You start looking for perfect squares in both columns. Haven't seen any yet. 15 and 35, no. So just keep going. And there we go, I've got 21 times 25. So I'm going to break this apart into 25 and 21. Circle your perfect square. The square root of 25 is 5. So I'm going to bring that out, and I'm left with the square root of 21. There's no perfect square still in 21, so you know you got the biggest. So that's 5 square root of 21. And then b, round the answer to the nearest hundredth of a foot. So I'm just going to go back to my calculator, and I'm going to type in 5 square root of 21. And there's my answer. You could also type in the square root of 525, and it should be the same thing. So if I round that, my answer is about 22.91. Okay, a couple more left. 67, simplify. Write your answer in scientific notation in standard form. Okay, so this is just scientific notation. I'm going to actually work this down here so I have more room. So I have 1.4 times 10 to the 5th divided by 3.5 times 10 to the negative 2. Okay, what's nice about this is since it involves exponents, we just use the same rules that we use for our other exponents. So you divide the coefficients, and then we're going to end up subtracting these exponents. So if I do 1.4 divided by 3.5, that's 0.4. So I have 0.4 times 10 to the, now here's where it gets tricky. Because when you subtract exponents, this is not 5 minus 2, it's 5 minus, because we need to subtract exponents, a negative 2. So that changes to plus a positive, which is 10 to the 7. Now you could type this whole thing in your calculator, but that's going to get you your standard form answer. Remember with scientific notation, there has to be one number, but only one number in front of the decimal, which means I need to move this decimal. Okay, so I have to move this decimal to be after the 4 to be in correct scientific notation. Now with my classes, I had a trick that I used with them. Since that was 0.4 and I'm making that one space bigger, a bigger number, these numbers go in opposite directions. So if that goes one bigger, my exponent's going to go one smaller. So this is going to be 4 times 10 to the 6th. That is correct scientific notation. Okay, but if I actually wanted to get that standard form answer, I have 4 times 10 to the, what was it, 6. And there's my answer. So 4 million. So that's standard form. Okay, if you type this whole thing in your calculator from the beginning, you either need to put parentheses around the top and put parentheses around the bottom, or you can do alpha y equals, and you can pull up your fraction, and you can type everything on the top and then everything in on the bottom. All right, last question, 68. You deposit $750 into a savings account that earns 4.25% annually. How much would you earn in interest in 8 years? How much would be in the account in 8 years? Okay, now you're going to be given this formula, so you don't have to have it memorized, but you need to know what to plug into this. Okay, so this is your growth model, and this is something that's growing, money in a savings account, so we're going to use this model. Okay, so I have y equals, A is your initial amount, which is $750, 1 plus. Now your rate, that percent, you're going to have to move that decimal over twice, so that's 0.0425, and then your time, that's 8 years. So I'm going to take that, and I'm going to type that in my calculator. So I have 750 times 1 plus 0.0425, and I'm taking that to the 8th power, and you get 1,046 and 33 cents. So $1,046.33. If I typed that in right. I think I did. Okay, so that's it. I would suggest doing this a couple of times that y'all have class time and outside time to work on this. So the final exam is going to be very similar. So if you understand these, then you will be good. Thank you.